Hey everyone, it's Mr. Canfield. This is AB Calculus, Chapter 40, Separable Differential Equations. Okay, so this is take two with a shorter introduction and less mistakes. So basically, we're going to be doing things we've already done, but looking at more complicated examples. So, like, let's say we had dy dx is equal to xy, and we were asked to find something called the general solution to the differential equation. That's what DEQ stands for. Another way that we'll see differential equation is with the word diffeq, D-I-F-F-Q. If you ever hear anybody talk about diffeq, they're talking about differential equations. That's D-I-F-F-Y-Q, but it's really D-I-F-F-E-Q. Whatever. Okay, so yes, this introduction is still shorter. So if I had dy dx is equal to xy, and I wanted to find what's called the general solution, what I'm going to do is I'm going to get the y stuff over on the left side. So we're going to divide both sides by y, right? So if we do that, we get dy over y, and then we multiply both sides by the dx. So now I've got dy over y is equal to x dx. And what we're going to do to find the general solution to this is, when we say general solution, we mean find out what y equals without any dy or dx left over. So like we're going to integrate it, basically. So this is separable, but then we get over here. These are not considered separable. And if you're like, well, what are you talking about? We'll just subtract y from both sides. Sure. Subtract y from both sides, multiply both sides by dx, right? If we do that, dy dx minus y is equal to x, and now we multiply both sides by dx. Over on the left-hand side, we get dy minus y dx is equal to x d. Oh, see how that y is stuck with it? There's still a dx over here. And we're trying to get all the y's and dy's over here and all the x's and dx's over here. We're trying to separate the variables. So it's so funny to me that plus is like the worst thing in the world. Addition's the hardest thing in math. Sometimes. All right, so what we're going to do is we're going to solve these. Oh, yeah, whatever. Okay, so we're going to solve these differential equations. So, like for this example here, this nice good start, we can multiply both sides by y, and we can multiply both sides by dx, and if we do that, then we get y dy is equal to 2x dx. So to find the general solution, what we do is we integrate both sides. And we're allowed to do this because we have a dy on this side and a dx on this side. We have the end of this sentence. We're allowed to introduce the beginning of the sentence because we have the end of the sentence. So if I do that, the right-hand side is easier. So we'll do the left-hand side first. So what would the integral of y dy be? Well, if you're like, huh? Just remember, this is the same thing as saying the integral of x dx. The variable doesn't matter. What matters is what's happening in there. So like the integral of x dx, it's a 1, so we would get x to the 2 over 2, right? Plus c. That's what it would be if it was x stuff. So it's the same deal here. It's going to be y squared over 2. Now, I could put a plus c here. We've talked about this before. When we integrate both sides, we're only going to put the plus c on one side because it's this idea of some rando number that I can put on either. So like I can, if this is a c and this is a c, then I can move the c's together and I get a different c. And so we wait to call out a c until the very end. So the integral of 2x is going to be x squared over 2. Oh, 2x squared over 2, right? So the 2's cancel. So it's just going to be x squared plus c. So I got to keep going though, because I'm trying to find what's called the general solution. And the general solution is going to be y equals. So now I have to solve for y. So I see y squared divided by 2. So I'll multiply both sides by 2. And this is where it gets a little silly. 2x squared. I am not going to write 2x squared plus 2c. Because, remember, 2c, 1c, 1000c, whatever, c some random number. I don't care what it is. So it's a constant. So I have some random constant. 2 times some random constant is still some random constant. This is a practice that you want to get in the habit of. All right, so now to get y by itself, I'm going to take the square root of both sides. And if you think the answer is the square root of 2x squared plus c, you're not right, but you're not like all the way wrong. I'd say you're half right. When we take the square root, this says something squared is equal to y squared. So, blah, blah, blah. Brain fart. Okay, sorry about that. Ooh, it smells. We need the plus or minus. Because the idea of a square root, when we bring it in, it's because we're saying, oh, yeah. Positive or negative, when we square this, it's going to wind up working. So like if this was a negative number and we squared it's positive, it's a positive squared positive. Oof, I don't think that was as helpful as I wanted it to be. Okay, so now let's get to this one. And you might be like, oh, sweet, we just multiply both sides by dx. So we get dy is equal to y squared d. Wait a minute. No. Hopefully you're like, no, that's not what you did last time. I need to get the y over onto the left-hand side, but I can't do it through subtraction. Remember earlier we did subtraction and that was problems. So what we're gonna do is we're gonna divide both sides by y squared. So 1 over y squared dy is equal to dx. So now I can integrate. And on the left-hand side, I'm gonna rewrite the integral as a more helpful form. This is y to the negative 2, right? So we'll add 1 to the exponent, y to the negative 1, and we'll divide by our new exponent. And on the right-hand side, wait, there's nothing in there. It's a 1, right? What's the antiderivative of 1? It's just x. So now to finish this up, I'll multiply both sides by negative 1. How does he expect anybody to get this? I don't write super big. All right, okay. So I get y to the negative 1, which is 1 over y, right, is equal to negative x. I'm still writing plus c. Who cares if it's a negative? All right. I want to get y by itself. I could multiply both sides by y and then divide by this stuff. It would be like divide both sides by the negative x plus c. I am going to instead take the reciprocal of both sides. It's the same idea. We get y is equal to 1 over the entire other side. That's valid. Why does Stu have... Oh, okay. Okay, he just has his negative in a different spot than me. Okay, never mind. We're good. Got scared for a second. Yes, I am checking my answers with Stu. I want to make sure I'm giving you guys accurate material. I make mistakes. In case you haven't figured it out over 40 chapters. All right. So this one's pretty straightforward. We're going to multiply both sides by, so left-hand side, we'll do 3y squared dy. Right-hand side, we get x plus sine x in parentheses dx. And now when I integrate, nice straightforward business. This is going to be 3y cubed over 3, right? Oh, then the 3's will cancel then, and we'll get y cubed. On this side, we've got an integral of 2 things added together, so we'll just get x squared over 2. Ooh, and I need to think about this. What do I take the derivative of and get sine? Because regular cosine would give me a negative sign, but I have a positive sign, so I need negative cosine. Plus c. And now we get to write our delightful answer. Well, we get y cubed. To get the y by itself, we'll take the cube root of both sides. Nice and simple looking. Just kidding. So pretty quickly, differential equations get really, really nasty. Here's the thing. We really just care about being able to solve them right now. I don't really care about how bad the answer is. So if these first 3 examples make sense, you get the general idea. In the next video, we are going to look at, so if you're like, I might need some practice, well then go find the first few in the homework. 4, 5, and 6 are gonna move us in a different direction, and I wanna start a different video with that. So hope this was helpful. Bye.